This question asks us to use the properties of logarithms to rewrite as a single logarithm and simplify. So our first question is 5 log b of x plus 3 log b of y minus 8 log b of z. Now there are 3 rules of logs we need to keep in mind. What are they? Well, the log of the product is the sum of the logs. The log of the quotient is the difference of the logs, and we can pull exponents down. So let's clarify that idea. Log b mn is log b of m plus log b of n. Log b of m over n is log b of m minus log b of n, and log b of m to the p, we can pull the exponent down, is just p log b of m. So we want to rewrite this as a single logarithm. So I'm looking at 5 log b of x. So it's like this. It's like p log b of m. I can pull that exponent up, and I can think of that as log b of x to the 5th. So I'm going to think about pulling this 5 up. Same thing here. Log b, 3 times log b of y is like p log b of m. Pull the p up, pull the 3 up. That will be log b of y to the 3rd minus 8 log b of z, same thing. So using that 3rd rule, this becomes log base b of x to the 5th plus log base b of y to the 3rd minus log base b of z to the 8th. So now I have these 2 things, log base b of x to the 5th plus log base b of y to the 3rd. That's the sum of 2 logs. So looking at my rule, sum of 2 logs, log b of m plus log b of n is log b of m times n. So it would be log b of x to the 5th plus log b of y to the 3rd is log b x to the 5th times y to the 3rd. So I can rewrite that this way, log b x to the 5th times y to the 3rd is those 2 guys, minus log b of z to the 8th. And then finally, I have this rule here, which is the difference. Log b of m minus log b of n is log b of m divided by n. So log b of this guy minus this is log b of this guy divided by that guy. So finishing up our last rule, log 5 of the first guy, x to the 5th y to the cube divided by the second guy, y cubed divided by log b of z to the 8th. So what will that give us? Of course, that gives us log 5 of x to the 5th y cubed times 1 over z to the 8th. I'm putting in a few extra steps, but you get the idea. You could have done it directly. Log base 5 of x to the 5th y to the 3rd over z to the 8th has enabled us to write that as a single logarithm using these 3 rules, right? These 3 rules govern the relationship between multiplication, division, exponentials, together with logarithms. So we had our original statement. We've rewritten it as a single logarithm. Let's take a look at our next question of that type. What do we have? 6 log base 4 of a minus 9 log base 4 of b minus 2 log base 4 of c. So let's write all that down. 6 log base 4 of a minus 9 log base 4 of b minus 2 log base 4 of c. So we have our rules. Same rule first again. P log base b of m is log base b of m to the p. I can pull the exponent up. So I'm going to visualize that here. The 6 is going to come up. The 9 is going to come up. The 2 is going to come up. So I get log base 4 of a to the 6th minus log base 4 of b to the 9th minus log base 4 of c squared. Now we're ready to go ahead and use this one. So if I focus on the first two, log base 4 of something minus log base 4 of something is log base 4 of something divided by something. So that will simply be log base 4 of a to the 6th divided by b to the 9th minus log base 4 of c squared. Okay. And again, I've got to use that divided by rule again. It's log base 4 of the first piece divided by the second piece, which I will write this way. Log base 4 a to the 6th over b to the 9th divided by c squared. Make sure that's a b, which is log base 4 a to the 6th over b to the 9th times 1 over c squared, which gives me my final answer, log base 4. Upstairs is a to the 6th, downstairs b to the 9th c squared. And again, with those three rules that we have here, we're able to rewrite this thing, which was a sum difference of multiples of logs, as a single logarithm by combining those terms. And I believe there is one more question of this type for us to look at. Log base 4 of 2 plus 5 log base 4 of 2. How can we make sense of this one? Log base 4 of 2 plus 5 times log base 4 of 2. Again, we have our rules. I'm going to do this rule first. Again, pulling the exponent up. 5 log 4 of 2 would be log 4 of 2 to the 5th. So this exponent is going to come up here. So I have log base 4 of 2 plus log base 4 2 to the 5th, which is 32, by the way. So I can rewrite this as log base 4 of 2 plus log base 4, 2, 4, 8, 16, 32. Now we have our rule that the sum of the logs, oh, you can't see any of this. Let's go back and show it. Again, log base 4 of 2 plus 5 log base 4 of 2. I pull the exponent up using my exponent rule. P log base b of m is log base b of m to the p. I pull the exponent up. So that's log base 4 of 2 to the 5th. 2 to the 5th, 2, 4, 8, 16, 32 is log base 4 of 32. So now I have log base 4 of 2 plus log base 4 of 32. But the sum of the logs is the log of the product. So I can think of this as log base 4 of 2 times 32. Log base 4 of 2 times 32, which is log base 4 of 64. I will say that equals z. No, I get 4 to the z equals 64. Let us look at our multiples of z. 4 to the 1 is 4. 4 to the 2 is 4 times 4, which is 16. 4 to the 3 is 4 times 4 times 4, which is 64. So I get 4 to the z equals 4 to the 3rd, so I get the z equals 3, which means log base 4 of 64 is 3, which means log base 4 of 2 plus 5 times log base 4 of 2 also equals 3.